Okay, so I'm going to send you these two files here. So one's a directory and one's a doc file. If you open up the doc file, I listed here downloads that you will need for everything to work. So the first thing we want to download is the number Python. I don't know if you have it already. If you do, don't worry about this, but you can easily just access this by opening the terminal and entering this command. I'm not going to do it because I already have it installed. I don't want to install it again, but I'm using Python 2.7 to install it. And so basically this command will install the pip for 2.7. And then using that pip, we can then install the number Python. So this is the easiest way to do it. I would recommend you to stay on 2.7 for the rest of this entire docking. So we want to download the number Python so that we can use this program called PDB2PQR. Now to download this, we can go to this link here. From the GitHub, we're going to go ahead and just download the entire directory. So let's go to downloads. It's almost done. Okay, once it's finished, we want to go into the direct. So if we open it, we get a better look at it. So basically, we want to go into, want to go inside, and we're going to see here that there's this PDB2PQR folder. This is where we want to go because this is where all the binaries are to compile the program. So the easiest way to do this, so where did we go just now? We went to APBS, and then we went to PDB2QR. Right in here, and in here we're gonna just compile the program to do so. I believe. Also, this uses the scons. Okay, so we're gonna do Python scons, and I believe in the scons there should be a there's a compilation program. Now to do this, we could just do Python compile. And it'll go ahead and it'll compile. It takes a sec, but it'll be fine. You're not gonna notice much of a difference, but something didn't happen. As is here, we can see there is no pdb2pqr.py file. There's an in file, which is the main file, but after we really want this file right here. Okay, so that is the first thing we want. Here you can see the build was succeeded. So now that that's done downloading, basically what we want to do is copy this entire folder. Okay, this will be the first step. Now this has to be done on your computer, which is why I'm sending you. I'm not sending it to you already in here. So everything in here can be transferred between computers, between different computers, without having to do something specific on a specific computer. So what we want to do is go ahead and place this entire, I'm going to copy this entire directory, and I'm going to place it in this receptor directory. I'm going to just paste it all. Actually, an even better thing to do would be to actually copy everything in here and just put it here. And so we don't really need that, where is it? This folder. It's copied. So everything will be in here. Now this is being a receptor, and I'll talk about it in a bit. So that can be transferred between computer to computer. It doesn't really matter. So that's the first step. Let's see what else we have to download. Okay, so we also download this MGL tools. Now this is exactly what ADT is, but this is the source code. It's not the user-friendly version that we have, that we're used to. So if we go to this link, it's probably the same link that you downloaded ADT with. And so usually we downloaded this one, but we're no longer going to do that. We're going to download the source version. And let that download. Okay, so let's prepare for that one. Back to CD downloads. I listed here also the commands in case you forget. They're all in red. So then, it's almost done. Okay, so that one didn't unzip, so we're going to do tar minus xvf, right, to unzip, and it's called mgl tools. Now we're going to let that unzip. Okay, now notice that this folder was created. Now this file here is again to compile all the binaries, so we're going to go ahead and install that. Oh, I'm not in the folder here. Go to md tools, and then we'll compile. And enter. It's going to make all these files. And you'll notice a little message here pop up at some time. And so you might get this if you're on the Mojava, the new one. If I remember your Mac, you weren't on the Mojava, so I think it'll be fine. But this is okay. Might as well not update later. But I can just hit OK. So when you get this message, it's done. So you hit OK. Everything's good. So now, why we did this is because we need certain tools from Autodoc. So you're used to it being called ADT. So we want to extract the scripts from ADT because we want to use them command line. So one of the most important things we need is the Python that they use, which is not the Python that's available to us. This is their special Python that Autodoc uses. And we want to go ahead and we want to put that in the prep folder. And so again, these are files that you can transfer between computers. So that doesn't matter. But this file here can't be transferred between computers. You have to download it on that computer and then put it on here. So I'm going to do that. We're going to need that file. We're also going to need some certain tools that Autodoc has. I believe they're in here. MGL. Oh yeah, so Autodoc tools. No. I think they're in utilities. Yeah, these are the tools we're going to need. So we're going to need this PDB Qt to PDB. And what else are we going to need? We're going to prepare the ligand, so we're going to need this. And we're also going to need the receptor one. I believe that's all. Yeah, that's all. Okay. So then that's done. So that was easy. So then we want to download Autodoc Vina. In case you haven't done this, I'll probably do it anyways. So you can copy the Vina and Vina split that you already have if you want, or you can go ahead and download them. I'm going to download it again for the sake of completeness. So again, it went in our downloads. So you can just tar it again. Go ahead and tar it. Makes this file. So these two are not, you can't transfer these between computer and computer. They're attached to different names when you do. So you gotta add your own. So that's done. What else do we need? So I think you have VMD, but I don't believe you have VMD in your environment yet. And so this isn't hard. Now I don't know if you have 1.9.3 or 1.9.2 or 1.9.4 or whatever. But you can check. You can check which one you have. Basically, we want to put this. So I'm going to show you right now. So we're gonna do CD, right? It's going to take you to your home directory. And this is where your bash.rc file is. Now here I have a lot of things, but it doesn't really matter. But you see this VMD here, this is what we want to make, right? Because we're going to need it when you run the scripts. Now it might be different on your computer than it is on mine. So I'm going to show you how you can edit this. This string right here will be specific to your computer. Maybe it's the same, maybe not, but it's important to get it right. Now if I go to applications and I find my VMD, okay, that didn't show. I'm going to show package contents. Oh yeah, so what we want to look for this VMD, this one file right here. So if we go to show package contents, we go here, VMD, and yeah, you see it's right here. So we want the path of that specific one. And so you can see that if you go to the get info on that one, you could just copy from here. You don't have to copy from the untitled. You can go then and edit this one as you saw. So mine won't change because, oh, okay, that didn't work out. I guess you can't copy it that way. Well, that's fine. You know what? We can just write this out then, this path here. So here you can see applications, then we can see VMD 1.93.app. This is the .app, the contents, the VMD, and all the way up to here. Now that might be the trickiest part, but I think you can get that. And so what we want to do is then, it just assumes that you do know how to use VI. So you do shift, colon, and all that other VI stuff. So for now, we're just going to insert. You're gonna just write out this line, alias VMD, and you're gonna write it out just this. So, okay. Then you go ahead and you're gonna save it. And that's it. There's nothing else you have to do for that. Now, so now you have all the files, I believe. I do believe you have all the files now to begin. Well, there is, okay, so those are all the files. Now that you have all the files to help you work, you're gonna have to just set up the stuff you'll need for docking. So those files you never have to touch again. You could just copy this. So you can copy this and duplicate it as many times as you want, right? That's up to you. Now how this works is you're gonna have to just do two things. So I know it's automated, but there is still some work you have to do. And that's you have to design the ligands on your own. That's something that can't be automated. But there is a wrong and right way to do so. And I've showed you how to do it with Avogadro. But it's not always the most efficient way. And so because you have a lot of editing to do even with Avogadro. And I want to show you why. Just so in case of future references, you get an error. You see, this is the output from Avogadro. Now, what's wrong with this and why it will fail later on in MD or when you calculate intermolecular interactions is that none of these atom names are unique. And when you run a program, this O can't be distinguished from this O, or this carbon can't be distinguished from this carbon. Likewise, you don't want to have an unnamed ligand as your residue name for this ligand, right? And so that's why, so this is what you would do if you got an output from Avogadro. Now, if you download this program called Maestro, I didn't include the link here, but I will afterwards. You can go ahead and download the educational version. And it's very easy to perform such an edit. So I'm going to show you what Maestro does. It gives you this unique PDB atom names, and it also lets you edit this lig name. And now this is very hard to do for a mol2 file. If you go online and you look for scripts to help edit They're practically non-existent. And so you can do your own, but I feel I did my own before, and I tend to get errors in little places because of this addition of characters and different rows. Sometimes when you try to construct multiple files using different charge models. And so it's annoying, but Maestro does a great way to that's a great way of organizing this in such a fashion that it can be read by other programs. It does this very well, and it adds this addition here, as well as a res ID number. So I'm going to show you just quickly how to do this, because this can be done very easily if you download Maestro. So if you open Maestro, let's say you upload this Avogadro multi file, right? Go ahead and upload. Okay, so this is resveratrol. Now it's very easy to go ahead and make those little edits to this multi file, because all you have to do is go ahead. You're going to use this build command. You're going to use this other edits. You're going to change. Oh no, that's not the right one. You're going to go ahead and change it and build. Oh no, it is other edits. Oh yeah, you're going to change atom properties. You're going to go ahead and include a residue name. So I always make it lig. It is the safest way across the entire docking protocol to do so. You don't have to add a chain name, but if you want, I always add a D because the program that I wrote will always write it in D too. And then this PDB atom name, this is the most important one. You want to set unique PDB atom names within the residues. You hit apply. Okay, so now it's gonna, so when you go ahead and export this molecule, and so the good thing about this is that I can upload one, but I can upload as many as I want. I can upload 10, 20, and I can go ahead and do the same thing for all of them if I just highlight all of them and do what I just did. And then I can just highlight all of them again. I can export the structures, and I can, so we don't want the Maestro version, we cannot put in mol2 file. We could say, let's do an example here. Let's go to home, let's just put it here. And I'm just going to use the same name. So here it uploaded it with star, but you can name it whatever you want. So here you can export each entry individually if I uploaded a lot. Or I can export them all in the same file. Now each one has their advantages and disadvantages. But for now we'll just do each entry individually. And so this will always stay the same. Everything else is fine. And I'm going to go ahead and save it. And so we'll see something created on the desktop soon. So I didn't change the name, but you could change it on your own. And you'll see how that it changed this Avogadro file into this into now this Maestro file, which is much better. Okay, so that's the explanation, because most of the programs will fail if you don't do this unique PDB atom name. That's important. So that's that. The good thing about this is that I already did this for you. Those are the ligands that I uploaded to the drive earlier. So I'm going to use Rosemary's ligands. Let me download them. Go ahead and download these. Okay, so as you can see, if you look at these, see they all have unique PDB atom names and they're all named lig. Now that's very important, and always do that before you start anything. Okay, now another rule to this program is that you have to name them in order. So you have to name them, oh, must have clicked that by accident. You must name them 1, 2, 3, 4, 5, 6. Alright, you can't include this resveratrol here. I didn't program it to include names like that. I just included them to include residue names like that. So make sure you know which residue is which if you really want to remember. So I'm going to go ahead and I'm going to copy this here. Now I can include as many residues as I want, 100, 200, whatever. Of course that will take a while, but it is possible. So now that we did that, What else do we have to do? So here I wrote it out. Design multi with Avogadro, then act unique PDB item names and residue names using Maestro. And name multi files. Now you have to edit the com file on your own. That's something that you also have to do. Now the com file is located in the prep directory. Here I labeled it blue, just so you remember. Now I left it blank. So you're gonna have to use Autodoc tools to go and edit and perform this. Now, I don't know, for this example, I'm gonna use what I used to perform blind dockings on BSA. So let's see. So this is 4RO. Let me just make sure this is correct. Receptor. Oh yeah, that is correct. Okay. So again, I'm not gonna go over how to find this because I believe everyone knows already. Now you don't have to edit this receptor PDBQT part. It will always be called that. That's what the program named it. But you will have to add these. So I can just copy paste this. And so the edit is done. So this is a blind docking, just to reiterate. Go ahead and leave that there. Once you've done that, that's basically everything. Now what it will do is, so if you understand the files, it will take all these ligands, right? And it will dock it to the receptor that we're about to create. I'll show you. Using this com file. So that means that also it will do all that however many times and repetitions you want, such that you don't have to go ahead and put all the files into one and click and click and click. I know how that can get annoying. Okay, so if you want to perform, so this is a blind docking. So say you want to perform one at site IA, IB, 2B, 2A, etc. Just go ahead, duplicate this file. Duplicate it as many times as you want. As if you can see this, I duplicated it 6 times here. One for this is blind, IA, IB, 2B, 3A, and 3B. So I did all that. And I performed it all at the same time, so I didn't have to wait. So you can do the same, right? Just edit the com file each time, right? This com file basically tells you where you want to dock these ligands to this receptor. In this case, it's a blind docking. Now, the last step is to go ahead and to launch the program. So to do that, we're gonna go ahead and go to this directory. So it's in desktop. Let's call it test for you. Then we're gonna go into prep. Now this is where the main script is. This script will perform the entire program. It links with 2 other scripts, so in case you ever want to edit, you can edit this script. The other script that it connects with is this VINA receptor. And that's it. There's no more other scripts. Now be aware that this one that I'm sending you doesn't include the arpeggio for many reasons, because over the last projects we've seen that to calculate the interactions between the ligand and the receptor right after docking may not be the most noteworthy, at least for publications. So for now, we're just going to do it this way, without arpeggio to calculate interactions. We're going to calculate interactions using MD. So we're going to go ahead. So the program is called VINA VS Prep. So we're going to go ahead. So let me make this clear. If this doesn't work, all you have to do is give it permission to. That's what this chain mod plus X does. You're going to have to give permission to this script here and to the script that I just showed you, the other one, the VNA receptor SH. Now that's pretty easy. And then you can go ahead and launch it. But sometimes it does work, sometimes it doesn't. But just be wary. After you give it permission the first time, you never have to give it permission again. So we're going to go ahead and launch this. So now this is for PDB ID code. Now, for BSA, we've decided to use, so I know initially we were using 4RO, but we're not going to use that anymore. Instead, we're going to use 3VO3, which has given us better results. Well, so if you press any other key, it gives you that, so you can just delete that. 3VO3. That's the PDB ID code. Go ahead, enter. Now it says chain of interest. Now we usually use chain A. If you are in doubt, you can always ask, but it's usually chain A. Now it asks us, how do we want to protonate? At what pH specifically do we want to protonate the receptor? Let's do it at physiological pH. That's just 7.4. Now it asks us, how do we want to optimize the receptor? Now, there's only one of the options work for now, and it's amber. Charm is another one that is also good. I'm going to try to get it to work later on. But for now, we're just going to use amber. I type amber. Well, since we're using the amber force field, we're going to use the amber output scheme. So starting residue number and structure file. Now, this is something you have to do beforehand as well, because there's no way of telling how the PDB structure was constructed, and they're all constructed differently. So here I see the crystal structure. Now this is important because many times you want to keep the same numbering throughout the simulations, just to observe. So here we can see that it begins at 3. And we know we're interested in tryptophan. And here we can see that tryptophan is labeled correctly, as it is in most papers. Now this is not the case in every PDB. Sometimes this could be tryptophan 133 and BSA, and that's not correct, but that's how it was numbered. And so this is important. So if we know that it started at 3 and that this tryptophan is labeled correctly, we want to keep this order in residues, right? So we're going to start it at 3 like it was in the PDB. Let me just double check. Where is it? Yeah, so we're going to start at 3. Go ahead, starting with the structure file. Now this is just a recap of everything it's going to do. The structure file is 3vo3.pdb. It will be extracted. Only chain A will be preserved. Everything that was co-crystallized within the PDB structure will be deleted. The structure file will be protonated at pH 7.4 and optimized. So this basically means we're going to add missing atoms. We're going to restructure the hydrogens in a better network. It's going to rename the structure. It's going to renumber the structure starting with residue number 3. And the final structure will be called receptor.pdb. And that's important. I'm going to go ahead and click Y to continue. Make sure that's all correct. Now you can see everything happening if you go back to the receptor. This first couple of steps basically prepares the receptor. It saves a lot of time because a lot of time is spent trying to get this receptor up to to standards, because look at this, it includes all these entries that we don't need. What we really need is all the atom entries. But even that, there's no hydrogens here, because when you co-crystallize, you can't really see all the hydrogens when you look at the X-ray scattering. And so then that's something else you have to account for. So luckily this does everything in just this one step. And so here's a note, so it finished. So it's going to check, so it says please check and edit the receptor PDB before continuing. And so I wrote this in because I know sometimes we want to use our own receptors, sometimes that we unprepared. So it is possible to use your own receptor. You just have to go ahead and replace it with this one before hitting continue. So I halted it here. But basically, go ahead and look at this receptor. It's pretty clean compared to this one here. This one's all dirty, you can say. So that's good. We want to see if all the trips are labeled correctly. So I see 134, that's good. That's how it's labeled in BSA. And 213, that's how it's labeled in BSA. So that's good. So we can go ahead and leave it like that. All the hydrogens have been added that weren't there previously. That's important. So it's good. So we can continue. But if you're not satisfied, you can go ahead and upload your own. You just replace this PDB at this step with your own PDB. And you can also see that there's no co-crystallized ligands. It's only residues from the protein. From this is the ending, and this is the start. No heteroatoms, no ligands, not anything. So we're happy with that. We can continue. What it's doing now, it's going ahead and transferring all the files needed into the respective directories in the prep. So you see, it's taking all the mol2 files, it's converting them into PDBQTs, all the work that we would have needed to do by hand in the Autodoc tools. Okay, so how many times would you like to run this virtual screening? No, that's important. We're usually repeating it 5 times. So it's going to repeat this notion of docking these ligands to this receptor using this CUM file. Right? That's the basic scheme. How many times do we want to do that is what this question is asking. We usually say 5. We could do more, but I think 5 is good enough. This is important, and it's good to not get this wrong. So here it says ligands default chain is D, so I changed it again in there to make sure that is the default chain for the ligands. And then it asks us how many ligands did you prepare for this screening. This you have to get right. Do not get this wrong or else you have to restart. So we did 6. So we do 6. Now it says about to execute 5 virtual screening runs for 6 ligands. That is correct. If it's not correct and you messed up, you can restart. Just hit N or type no. And you can just start from the beginning. So I'm going to continue. And here you'll see all of those documents that we formed. Now here, you're just going to sit and wait it out. So I'll pause it here, and you'll see, well, before I pause it, you'll see all these virtual screenings created. So they're already created in separate folders to organize it. You can see here that it's doing ligand 1, it's creating a log file. And you see once it's done, it moves on to the next one. Ligand 2, it's going to go ahead, and you see here's the out file. And it will do the rest for you in a bit. I'll show you that when everything's done. Is there anything else? I think that's it for now. I'll resume it once it's done.